In this video, we're going to be talking about what's known as the activity series. The activity series of metals describes the relative ability or relative reactivity of a different series of metals. When we talk about a metal reaction, generally what we say is that these metals, potassium for example, when it reacts, is going to form an ion, K+, and is going to lose an electron. So what we're saying here is that this potassium is undergoing an oxidation reaction. So the concept here is that in this series, the ones at the top of the list are most easily oxidized. If we look at some of the members of the elements here, and we think about experiences we've had, that probably makes sense. We know, for example, the potassium and sodium are stored under oil to protect them from air and to protect them from moisture. Way down at the bottom, we have things like platinum, gold, silver, and copper. We know that gold is used, for example, as electrodes on electronic devices because it doesn't react with oxygen very easily. It's not very easily oxidized. The purpose of this series is to make a prediction and ask a question: what happens when two substances react? For example, if I had a reaction of potassium metal and it was going to react with sodium chloride, sodium +1, and Cl -1, would a reaction take place? And so if potassium is more easily oxidized than sodium, the idea would be that potassium could turn into a potassium +1, combine with the chloride, and generate metallic sodium. If that was the case, then we'd expect at the reverse reaction, where we have K+, and so we have K+ and Cl-, and Na would not occur. And that's the observation. So by taking a look at these processes here, this activity series, being aware of its construction, then we have an ability to be able to look at a series of elements and predict whether reactions are going to occur or not occur. Looking at this top reaction, we notice that the potassium has become oxidized, and here the sodium, consequently, has become reduced. So another way of talking about this list is we can say that those things here, which are most easily oxidized, are able also to facilitate another process, which is reduction. So we find out that essentially the top of this list, the most easily oxidized, act also as the best reducing agents. We're also going to learn that this activity series is kind of a prelude to what happens when we start talking about making batteries. That we're going to be able to get the idea that electrons are going to be able to flow from one material to another. And based on the location on this chart, we might think about electrons flowing from potassium to anything that's down below it. And therefore, if we talk about batteries, we'll soon discover that there are batteries that contain things, for example, like zinc, copper. And the process that takes place in those reactions is actually a redox reaction, where electrons are going to be flowing from one of these materials to the other. The battery is going to work because we harness that process. But for now, we're going to be talking about it just in the perspective of predicting possible aqueous reactions.